At a picnic, there are 10 diet drinks and 5 regular drinks in an ice cooler. There's also 8 bags of fat-free chips and 12 bags of regular chips in a basket. Without looking, what is the probability you grab a diet drink and a bag of fat-free drinks? So this is your first one, probability of A happening. Here's the second one, probability of B happening. And these are independent events. So I want to know, what is the probability that both A and B occur? Bless you. Probability of A times probability of B. So diet drinks. There's 10 diet drinks and a total of 15 drinks. There are 8 fat-free chips and a total of 20 chips, bags of chips. So P of A is 10 out of 15. P of B is 8 out of 20. And I'm going to use the calculator to get the final answer. 10 divided by 15 times 8 divided by 20. And I'll use the calculator to reduce the fraction. Math, fraction, enter, enter. 4 out of 15. A jar contains 4 blue marbles and 2 red marbles. Suppose you choose a marble at random and you do not replace it. So by not replacing it, more than likely all of these problems are going to be dependent. Then you choose a second marble. Okay, so we're always going to do 2 events and we're never replacing. That makes all of these dependent events. Find the probability of each event. First you select a blue, so there's your first event. Then you select a red. Remember, you are not replacing. So probability of A and B occurring. So probability of A times the probability of B, assuming A occurs. So what's the chance of getting a blue? So there's 4 marbles that are blue, and there's a total of 6 marbles in all. There are 2 marbles that are red, but remember, when you go back in to draw, there's no longer 6 marbles, there's now 5, because you did not replace the first blue marble that was chosen. So 4 out of 6 times 2 out of 5. 4, 6, and 2, 5. Math, fraction, enter, enter, and I'll get you the reduced fraction of 4 over 15. On to B. One of the marbles you select is blue and then blue again. So you're going to choose blue consecutively. So one blue and then the next blue. So P of A and P of B. What is the probability of choosing A and B? And we know they're dependent because you're not replacing the first marble that's chosen. So the chance of getting blue, well, there's 4 blues to start with in the bag and 6 total marbles. Now you choose one of the blues and you don't replace it, giving you 3 remaining marbles and 5 total marbles to choose from. Oh. 2/5 for an answer. Okay, this time you select a red marble, first event, and then a blue marble, second event. Again, without replacement makes it dependent. Probability of A. What's the chance of getting a red? Well, there's 2 reds and 6 total. We keep one of the reds, and now we're going to choose a blue, assuming we chose a red first. So there are 4 remaining blue, but instead of having 6 marbles in the bag, there are now 5. So 2 out of 6 and 4 out of 5. Please make sure you're checking your answers in the back. So 4/15. Okay, what's the chance of them both being red? Because exact same thing as this problem here, just worded differently. Both blue, now they're both red. So probability of a red and a red second. So probability of red, and then probability of choosing red a second time, assuming the first time was red. So to start with, there's 2 red and 6 total. And now we're going to keep one of those red. So when we go back into the bag, there's only 1 remaining marble that's red and 5 marbles to choose from. So 2 out of 6 and 1 out of 5. Hey guys, can you lower your volume, please? Priscilla? Thank you. 1 out of 15. Okay, the third one. The ACT math exam is a multiple choice assessment that contains 5 choices for each answer. With time running out, you are forced to begin guessing randomly. Suppose you make a random guess on 5 remaining questions. What is the probability that you will answer all 5 correctly? This is an example of independent events, and there are 5 events occurring because you have 5 remaining problems that you are going to guess on. And because they're independent, we write them like this. So what is the chance of getting the first one right? 1 out of 5. What is the chance of getting the second one right? 1 out of 5. The third one, 1 out of 5. The fourth one, 1 out of 5. And the fifth one, 1 out of 5. One times 1 times 1 times 1 times 1 is 1. And 5 times itself 5 times is like taking 5 to the 5th, 3,125. Suppose a number 1 through 100 is selected at random. What is the probability that a multiple of 4, and this should be or 5, is chosen? So first let's identify all the numbers between 1 and 100 that are multiples of 4 or 5. Remember, or means it's the union, so we're going to push everything together and we can never repeat. Never repeating is the key. So I'm going to start by writing down all the multiples of 4 and 5. So let's do 5 first. It's the easiest. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So all multiples of 5 between 1 and 100. Now I'm going to do the multiples of 4. But if I ever look above, Kalvinder, please focus. If I ever look up above and see that I've already listed one of them, I can't consider that because we can't repeat. So 4, 8, 12, 16, 20. But we can see 20 is up above, can't repeat. 24, 28, 32, 36, 40, can't repeat. 44, 48, 52. 56, 60, can't repeat. 64, 68, 72. 76, 80, can't repeat. 84, 88, 92, 96, and 100, and you can't repeat the 100. So I'm going to count how many items do I have here that are multiples of 4 or 5. Again, we're not repeating. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. And count once again just to make sure, since there's a lot, that I didn't make a mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay, so the probability of A or B occurring is 40 out of how many choices? 100. Now reduce that fraction, and you can do it using a calculator, or you can do it in your mind, whatever you prefer. Just as a review again, The quick way, now obviously most of us are going to do this in our head, but the quick way when you do this is you hit math, fraction, enter, enter. And that gives it a reduced fraction, in this case, of 2/5. Okay, you randomly choose a colored marble from a urn that contains 4 purple, 6 yellow, and 10 green marbles. Find the probability of choosing purple. Okay, so from this container, we are going to choose a purple. So the probability, and you can write purple out if you want, or you can put an A for event, A occurring. We just have one event. What's the chance of getting a purple? A 6. How many total are there? 20. And when you reduce this down, again, P of A would have been just fine too. Reduce this down, you get 3 out of 10. You randomly choose a colored marble from a bag that contains 9 purple, 6 yellow, and 3 green marbles. Find the probability of choosing yellow. Okay, so we're going to go back to simple probability here. Feel free to write P of A. We have a total of 6 yellow and a total of 18 in all. So 1/3 is your reduced. Remember, you have to reduce everything. And that's the first page of your homework.